All right, so we're going to take a look at the second part of chapter 11.1. This time we're looking at range and standard deviation. Range and standard deviations are both measures of spread or of variance in a data set. And these are just two ways that we can see how it helps describe how the data is shaped, especially when you combine it with one of the measures of center we learned earlier. It helps to give a better idea of what our data set is looking like. So our range is pretty straightforward. It's the difference between the highest and lowest values. So if your highest value is 100 and your lowest value is 0, like say on a test, your range is 100 points. The standard deviation is a lot more complicated. The standard deviation is a calculation that represents how far a point is from the mean typically. So it just represents how far away points normally are from whatever the arithmetic average or the mean is. And it gives us this big formula. We have this symbol here. This is called sigma. And we have this big, huge square root formula. So let's actually look at the formula because it can be a little bit difficult to grasp. We're going to start at the bottom of the fraction. The bottom of the fraction is n. N is the number of data points. X bar, hopefully you remember this from our last video, X bar is the mean. So that's what we get by adding up all the data points and dividing by the number of data points, which is n. And what we do is we take all of the data points, which are x1, x2, x ... xn, and we subtract them from the average and then square that and combine them. And then divide that by n, we take the square root of the whole thing, and that gives us our standard deviation. So the x values in here, other than x bar, which I'll refer to as xk, the x values are data points. So this stuff that's on the top just means we take every data point, we subtract the mean from it and square it. Now, you might have some questions about this formula. I'm not going to explain where the formula came from, but I will point out a few things. The first one is the reason why we square this and then take the square root. You might say, why are we bothering to square and take the square root of all this junk? The reason why we're doing this is because if we didn't square it, every time you subtracted a number from the mean, like if you subtract a number from the mean, you might get a positive or a negative number, depending on whether or not it's above or below the average. The problem is that if you don't square it, then you have some differences that are positive, some that are negative, and they end up canceling each other out. And as a result, it'll look like we have much less variance than we actually do. So that's the reason why we need to square it, because the squaring it gets rid of that, that problem. And then we take the square root in order to make it into the standard deviation. Prior to actually taking the square root of this, if we just looked at it without the square root, that's actually called the variance, aka sigma squared is our variance. But we're mostly just looking at our standard deviation here. Each one of these individual subtractions we have is what's known as, and after we square it, each one of these individual subtractions, I should say, is actually the deviation. It's how much each data point deviates from the mean, meaning in English, how far away it is. So we're going to go ahead and we're going to find the range and the standard deviation of a data set. And this data set is the number of students in a class who are playing a sport and how many sports they're playing. So it's just how many sports each student is playing. Sports each student is playing. And I already put the data in order. There we go. There's our data set, 0, 0, 0, 1, 1, 1, 2, 2, 2, 6. And the first thing we need to do is if we're first gonna find the range. And the range is thankfully really easy because our highest number is 6, our lowest number is 0, 6 minus 0 is 6. We have a range of 6 sports. This will be a lot more difficult if the data is not already in order from smallest to largest. But in this particular example, I was nice, so it was a lot easier. Otherwise, you have to sort of hunt through the data, which can be pretty annoying. But we have our range of 6. Now we're going to calculate the standard deviation. And calculating the standard deviation is, of course, not going to be easy. And this is the reason why generally, I like to have students do the standard deviation by hand once, just so they can get a feel for it and then spend the rest of their lives doing it on the calculator like a normal human being. Okay, so in order to calculate our standard deviation, we must first calculate the mean for our X bar. So X bar is equal to, all right, I'm going to quickly calculate this. We have 3, 6, 9, we have 10 data points. And we have 3 zeros, so I'm going to do 0 times 3. We have 3 ones, so that's plus 1 times 3. We have 3 twos, plus 2 times 3. And then we have 1 6, so that's 6 times 1. So as you can see here in my mean calculation, I've actually just multiplied every distinct data point by the number of times that it appears, because I didn't want to write 0 0 0 3 more times, 1 1 1 3 more times, or just didn't want to. I wanted to save a little bit of space and time. When we do this, 0 times 3 is 0, so that goes away. 1 times 3 is 3, 2 times 3 is 6, and 6 times 6 is 6 times 1, excuse me, is 6, still divided by 10. 3 plus 6 plus 6 is 15 divided by 10. Our X bar is 1.5. Okay, so that was step 1. Now step 2 is we actually need to set it up. So let's go ahead and write this down. I'm going to try and make sure that we still can see the formula as I plug it in, and you can see this written out in all of its glory, at least this one time. Oops, that's sigma. That's not supposed to be curly O. Okay, so we're going to have a square root symbol in here, and we're going to have a big, long fraction. So our first data points, we have 3 zeros. So we're going to do 0 minus 1.5 squared plus 0 minus 1.5 squared plus 0 minus 1.5 squared. And you can see where I'm going from here is the next one will be 1 minus 1.5 squared. And I'm going to go ahead and pause the video while I put all this stuff in, because you don't need to watch me write it all down. Okay, so as you can see here, I actually needed to fold the page up because I didn't have nearly enough space to write down all 10 the points being subtracted from 1 point, or having 1.5 subtracted from all 10 points, and then squaring it. So that's what the standard deviation looks like all the way by hand. And if we go ahead and go through and actually calculate this, what we end up with ultimately is we have sigma is equal to the square root of 28.5 divided by 10, which is then the square root of 2.85, which gives us a sigma, or a standard deviation, of approximately 1.69. So that is calculating the range and the standard deviation. In general, you're going to want to calculate your standard deviation. Heck, you're going to end up calculating your range and everything else by entering it into a graphing calculator and then having it run the statistics suite that is included on most graphing calculators. There's also a variety of resources you can find to do this online, but that is the gist of how to find the range and the standard deviation of a data set. This standard deviation right here, the 1.69, represents, essentially speaking, how far away typically every data point is from the mean of 1.5.